So what I want to do is do a little bit of question 12 from section 9.1. So what I want to do is use Excel to find the sample correlation value R. So the question 12 talks about you have a table that shows ages of 11 children and how their ages ties in with the number of words in their vocabulary. So some things I want to do is I want to do the scatter plot. I want to calculate the sample correlation coefficient R using Excel. And also we have to compare R with the critical value uh, that we get from our table. So I'm going to just kind of do these three things here. So I'm going to go to the Excel spreadsheet. So I've went on and exported question 12 out to the Excel spreadsheet. So I've now have already uploaded it. Actually, I downloaded it onto my computer. Now, to do a scatter plot, what we can do is highlight the data, and then we can hit insert, and then we come over here to charts, and the first one is scatter. Click that, it generates it. I can now grab it and kind of move it somewhere. Let's see, we'll just move it up to about here. So that generates our scatter plot. Now, what we can do is click on the chart by just clicking in this area. I then get these little tools here. So I hit the plus sign. I can add axes titles. So if I check that box, I can then go down here to the X or the horizontal axis, click on it. And then the X was age, so I can type in age, hit enter. Well, got to spell age correctly. Try that again. Age, hit enter. And then on the vertical, we have vocabulary size. So if I type in vocabulary size, we hit enter, that gives us that. So notice how as our ages are increasing, we're seeing a positive correlation with the size of the vocabulary. So as you get older, you're kind of seeing the number of words you are familiar with increases. Sometimes you have to fix the X and Y axes, but based on the way my data is displayed, it looks like this covers it very well. So that should be a decent sample of your scatter plot. Now, another thing we can do with this data, so if I highlight the whole thing, if I go to data and come over to the far right, there's data analysis. And if I click on correlation, click OK. Actually, I got to highlight it now. Try that again. So highlight it again. And I did include the labels, so we'll click on labels there. So labels are part of it. If I click OK, this should create a little bit of a table for us. So that's how it creates a table. And again, if I kind of break this out a little bit, vocabulary size, age, and if I drag this out a little bit more, vocabulary size. So notice how the R value is actually this value right here, this 0.971199. So if we round it through decimal places, that's going to be 0.971. So if I go to here, our R value is going to be 0.971. Now, the critical value, we have to know the sample size, which was 11, and we need to know the level of significance. So the level of significance for this question, let's see if they gave us that. Uh, go back to that question there. Question 12. So to do our level of significance that was given in our problem to be this point oh 0.01. So using that in our table, so if we go to our table, if we find point oh 0.01 and 11, this gives us our rho value, which we compare it with our um, our R value that we found. So we're getting this 0.735. So the absolute value, so our critical value here was 0.735. Since alpha was 0.01, we get that from the table. So if the absolute value of R is greater than this rho value, so in other words, if the absolute value of 0.971 is greater than 0.735, so and actually it is, then what we say is there is a significant correlation here. So there is a significant linear correlation. So we could find that R value using Excel. We could find the critical value using our table and the absolute value of this correlation coefficient. Since it's 0.971, notice how that's greater than our Pearson correlation coefficient, which they use rho for. When that's true, then we say there is a significant linear correlation. Otherwise, we would say there is no significant linear correlation. So it kind of walks you through how Excel can help us identify this R value.